Okay, so let's go over that little lab that you did and talk a little bit about sampling strategies, and we'll also continue our discussion of ethnoarchaeology and look at the nut site that you guys did last week and sort of explain the whole purpose of that. Okay, so you chose 24 squares completely randomly. And then you devised your own sampling strategy, which was 24 different squares. Here were the locations of the sites, and so you might have gotten different results depending on the sampling strategy. Well, sampling strategies are important in the social sciences, and obviously not just in archaeology. But if you were doing a poll, let's say, you wanted to see, okay, which candidate is up in Ottawa County, or which candidate has more potential votes in Kent County. There are different ways to do it. Obviously, each strategy, as we're going to see, has its own advantages and disadvantages. Now, so I'm going to compare each of these strategies to sort of that example of voting polls, so you can sort of see the parallels. Okay, so imagine you were doing, some of you guys might have decided to do this strategy. This is known as non-probabilistic sampling. That is, you sample where you think you're going to find sites. That is, if things show up on the aerial photo, and some of you might have decided to do this, that look like sites, like, oh, okay, this looks like a feature. We learned about remote sensing. I'm going to sample all these squares where I think there is a site. That's non-probabilistic because you're taking probability out of the equation. There's advantages and disadvantages. The advantages are pretty obvious. Right? That is, you're probably going to have more success, potentially, because you are looking where you think there are sites already based on some other information. The disadvantages are that you're not necessarily going to get a representative sample, right? So if you, let's say, presented this information, you said we've identified these sites, and then someone asks you, well, how do you know people weren't living close to this river, or how do you know people weren't living in this area? You wouldn't be able to say, well, I know they didn't live there because I sampled it, because you didn't sample it, and so your sample is not representative. If you evenly sampled other parts of the landscape, then you could say, yes, we sampled other areas and there were no sites found there, right? So non-probabilistic sampling has its drawbacks, but also its positive features, right? So an example of this in the case of the polling, might be, you decided that you are going to only poll, let's say, people are going to vote, but you're not actually polling, let's say, people who might vote, maybe people who might register to vote. You're sort of polling people who you're pretty clear will vote. And so that might not necessarily be accurate because there might be some other voters out there that you missed. That's sort of my take on non-probabilistic sampling. All right. Okay. You guys chose the first strategy, or I chose it for you, was simple random sampling. It was completely random. Now, the positives, I guess you could say, is it takes any sort of bias out of the equation. But the negatives, you can see, are pretty obvious. It may not be successful, but also these samples are not evenly distributed on the landscape, right? And in fact, I'm sure many of you got clusters, right? So dense groupings. Now, why would that be? If it's completely random, if this square is chosen, right, the probability that this square will be chosen is identical to the probability that this square will be chosen or that square will be chosen, right? So that is, there's nothing in the algorithm to say evenly distribute these, right? Every single time it's completely random. So you may end up getting clusters. So in the polling strategy, this would be, someone hires you to say, go into Kent County and figure if this candidate is up. So you get a list of the whole population of Kent County. You tell the computer, pull out 2,000 people. You sample them and you get the numbers. And then you go back to your strategy, and it turns out that 75% of your sample was men, 25% women. And that's just the way it's skewed. And it doesn't actually represent the actual population. So that's the problem with simple random strategy. These are the kinds of strategies that you're going to use when you do your cemetery project, which we're going to talk about more at the end of this week and also next week. But sometimes people are confused when they hear simple random strategy, because sometimes when students go into the cemetery and they walk down the aisles and they choose, they just kind of point to a grave and they say, I'm going to choose that one, I'm going to choose that one, I'm going to choose that one. They think that's simple random strategy. It's not random. But if you are selecting it, you are still biased. You are still doing the selection. You might think you're being random, but completely random has to involve usually some sort of algorithm, the roll of the dice, a computer, etc. So simple random strategy is okay for some things, but it has many drawbacks. Okay, so what if you said, let's say your polling strategy, all right, 48% of the population is men and 52% of the population is women in Kent County. So of my 2,000 number sample, I'm going to make sure that 48% of the 2,000 are men, and I'm going to make sure 52% are women. This is what's known as stratified random sampling. Stratified random sampling, your sample is going to be proportional to the actual reality, to the whole population or the whole landscape. So in this archaeological case, right, you've got uplands or hills, and you've got lowlands or valley. The valley is about 3/5 of the area of your survey. The hills are about 2/5 of the area of your survey. So 2/5 of your squares will be randomly selected from here, and 3/5 of your squares will be randomly selected from here. That is what's known as stratified random sampling, right? So you could stratify a sample by, if you're doing a human population, gender, economic class, ethnicity, etc. Right? That is stratifying. You're stratifying your sample into different categories. Okay, some of you may have chose a systematic sample, right? Example, that is, you want to sort of evenly spread your units. So you might have said, I'm going to sample every 5th square, right? And the positives of this is that you are kind of evenly spreading things out over the landscape. The drawbacks are, again, you may potentially miss something. So, each of these, again, has their advantages and disadvantages. So in, let's say, your polling example, you might decide, I'm going to choose every 100th name in the list to ask a question, that kind of thing. So you can see, you kind of get this nice sort of even mesh. That's systematic. Why is it called systematic? Because you're coming up with a system. You're coming up with a rule. Every 5th square, every 10th square. You're systematic about it. So there are advantages and disadvantages. One disadvantage I heard of with systematic sampling just happened that these archaeologists were sampling a Roman site, and they decided that they were going to systematically lay out units to excavate. Well, it turns out that the Romans were very systematic in how they built the site. And the archaeologists were unlucky because their systematic sample, that they chose missed houses and only found streets. Right? So their system and the Roman system overlaid each other in such a way that they actually missed the houses. Right? So that's sort of, that doesn't happen often, obviously, but that's another sort of potential thing that could go wrong. Okay, this last one, stratified systematic, I think is the one that students have the hardest time in understanding. So I'm gonna try and explain it. You're using stratification. You're also being systematic in some ways, and you are being random. Right? You're really combining random and systematic. So it's stratified systematic is a little bit of a misnomer, right? But what you're doing is you're trying to combine techniques so that you make up for the positives and the negatives of each technique, right? So what you are doing is first you want to be systematic, right? And the way you do that is you have larger squares. Right, so you divide this whole up rather instead of these smaller squares, you kind of divide this up into large squares, and you decide, okay, each of my samples, and this is where kind of the stratification comes in. You know, I have, let's say at the very end, you have 9 large squares. So 1/9 of my sample will be here, 1/9 will be here, 1/9 will be here, etc. And then those samples within each of the big squares, you randomly select. So it's got a little bit of randomness. It's systematic because it's evenly spread or more evenly spread than, let's say, just a completely random strategy. Okay, so survey is very, very useful because, one, it helps you locate archaeological sites, but also, as we're going to see, you can get a lot of information from survey even before you excavate. And there are archaeologists who specialize and only do survey. They never excavate, but they get so much potentially good information. They can publish articles and come up with new discoveries based only on survey, right? Locating sites, dating the sites, right? Figuring out how big they were, and looking at that change over time. You could actually learn a lot about an area. So there are different kinds of size sites, right? Centers, so you could have a city, maybe a smaller city, a village, a very small village, like a dispersed village, a tiny hamlet, right? Maybe only 50 people in it or something like that. So if you're doing this in the Middle East, you would do some surface survey, looking at pottery on the ground to try to locate sites. You might look at features. You would go to tells, drive to the tell. And with all these sites, again, you could collect the pottery. And then if that area had been studied, you can say, oh, look, we've got Iron Age pottery or early Bronze Age pottery. We got Middle Bronze Age period pottery. And so you can date when that site was occupied, and you can estimate the size of the site. Now, what can this kind of thing tell you? It can tell you a lot of really useful information. I'll give you an example. This is southern Iraq, or what it was ancient Mesopotamia, around the time that the first civilizations arose. Right? And this is just at the beginning of that period, and this is at the end of that period. Right? Each of these dots represents an archaeological site. The size of the dots represent the size of the site. This is for, again, the early period and the late period. Now, one of the things archaeologists notice, and which you can actually see here, is that there's kind of a shift south in where people are living. Right? Then the next thing they looked at is the number of sites. If you count up and you see all these tiny dots of these small sites, right? There's actually more sites here in the beginning and fewer sites when civilizations or states emerged, which is kind of maybe the opposite of what you'd expect. Some people would say, oh, civilization arose because the population got bigger and bigger and bigger and bigger. That's not actually what's going on here, right? The number of sites is decreasing. Now, what about the size of the sites? The size of the sites are increasing through time. So just from survey data alone, right, measuring the size of the site, using the pottery to identify the time period, what we know is during the rise of civilization in Mesopotamia, small sites were disappearing and sites were getting larger. What that shows is that people were leaving their villages and migrating and going to larger cities. So it wasn't that the population was increasing. It was that the population was moving and clustering into larger settlements, which became the beginning of civilization, which became the very first cities in the history of the world, right? So survey data tells you that. They didn't actually excavate to get this information. It was all from survey data. So you get regional perspectives, right? That is, you can sort of understand, okay, what's going on in the entire region. If you were doing something like this for trying to figure out if a chiefdom rose or if a state arose, what you could do is you could look at the survey data, right? So if you surveyed an area from a certain time period and you found multiple villages of about 100 people each, all the villages are the same, right? You would say that that's probably a big man society. Later on, if you find a large village with smaller villages kind of clustered around it, you might say that seems to me like a chiefdom, right? Because now you don't have sites all the same size. Now you have one site with maybe a few thousand people and all these other small sites. That seems to indicate a chiefdom, not a tribe or a big man society anymore. Okay, so all this deals with the whole strategy that you're going to have to do your research, where you have, let's say, a question, you try to apply for money to support it, you conduct a survey. Sometimes the survey is sufficient to answer your question. Many times, though, you will need to pick a site to excavate, which is what we're going to talk about this week, excavation, and then the analysis of all of this. Okay, so this is going to be the end of this video. Next video, we're going to look in more detail at ethnoarchaeology and experimental archaeology that we did some work on last week.